Trigonometric integrals part 2. In part 1 we looked at even powers of cosine and sine. In this video we're going to look at integrals where at least either cosine or sine, one of them is to an odd power. I find the odd powers the easiest to deal with. If you have an odd power of cosine, like we do here, we've got cosine to the 5th power. If you have an odd power of cosine, then spin off cosine. Rewrite the resulting even power of cosine in terms of sine, and then use u equals sine x. I'll show you how it works. First, spin off cosine x. Notice that I have cosine to the 5th. I rewrote it as cosine to the 4th times cosine. Then I want to write my cosine to the 4th. I want to write it in terms of sine. To do that, I first rewrite cosine to the 4th as cosine squared squared. And by writing it that way, I can use my Pythagorean theorem. So cosine squared, I know that equals 1 minus sine squared. So I have rewritten my even power of cosine in terms of sine. Next, I make the substitution u equals sine x. Now if u equals sine x, what's du? Well, du would be cosine x dx. And here's the idea, that cosine x that we spun off, that ends up being part of my du. So it works out in just a really nice way. And now you can go ahead and do your substitution. Instead of your cosine x dx, put in du, and instead of sine, put in u. So instead of sine squared, I have u squared. Now notice that I have 1 minus u squared. That's being squared. And you have to go ahead and do that multiplication. So after you do that multiplication, you're all ready to integrate. And the integration is pretty straightforward. After you integrate, go ahead and substitute back. And you're all done. Like I said, I really like odd powers. I think they're fun and for me a little bit easier than the even powers. Let's do another example. And this time we have sine to an odd power. So I'm going to spin off sine this time because that's the one that's to an odd power. Spin off a sine and rewrite the resulting even power of sine in terms of cosine. And then do a u substitution, u equals cosine x. So instead of sine to the 3rd, I have sine squared times sine. Notice that I moved the sine that I spun off. Notice that I moved it over next to the dx. And the reason for that is just as we saw before, that sine x is going to be part of my du. So you might as well just move it right over next to your dx. Alright, now I want to rewrite the sine squared. I want to rewrite that in terms of cosine. So again, I just use the Pythagorean theorem. Sine squared equals 1 minus cosine squared. And now that I've written my, my even power of sine in terms of cosine, I'm now ready to do my substitution. So have u equal cosine of x. If u equals cosine x, what's du? Well, du equals negative sine x dx. So just as we suspected, that sine x that we spun off, that becomes part of my du. Now sine x dx together, that's equal to negative du. So we have to pay attention to that negative. So go ahead and do your substitution. Instead of sine x dx, put in negative du. Instead of every time you see a cosine, just put in u. And this is what it'll look like. Notice that I put my negative out front. You don't have to do it, but I like to do that. Next, I'm going to distribute u to the negative 2 power. So I'm going to go u to the negative 2 times 1, and then u to the negative 2 times u to the 2. And this is what I get. I'm now ready to integrate. So I integrate, and before I substitute back, I really would like to simplify this. And when I simplify it, notice that all my negatives drop out. And now I substitute back. And if you want, you can rewrite 1 over cosine. You can rewrite that as secant. And if you do, your answer will look like this. Take care and have a great day.